Hello everybody. Today's our chapter is conversion of trigonometric ratios. In this lesson, we will show that any trigonometric ratio can be expressed in terms of other ratios. Let's take an example. We are expressing all the trigonometric ratios in terms of cos A. Here it is cos A equals to cos A. That is expressing cos A to the cos A itself. Now sec A. We already know the formula that sec A equals to 1 by cos A. Here sec A is expressed in terms of cos A. We also know one more formula, that is sin A equals to root under 1 minus cos square A. This one also in terms of cos square A. So sin A is also expressed in terms of cos A. Now cosec A. We don't have direct formula to change cosec A in terms of cos A, but we know the formula cosec A is 1 by sin A. Now what we do is numerator as it is and sin A is replaced by its formula root under 1 minus cos square A, so that cosec A expressed in terms of cos A. Now for tan A we have the formula sin A by cos A. We are going to express it in terms of cos A. So cos A copied as it is. We are going to use the formula for sin A only. Here it is cos A. And in the numerator, we have to replace it with its formula root under 1 minus cos square A. Look students, tan A is also expressed in terms of cos A. Now one more ratio left over. It is cot A. Its formula is cos A by sin A. Numerator itself in terms of cos A. So only we have to replace the sin A. Here it is sin A is replaced by its formula root under 1 minus cos square A. And in the numerator cos A. Now cot A is also in terms of cos A now. All the ratios cos, sec A, sin A, cosec A, tan A and cot A are in terms of cos A. Students, I think you have understood the concept of conversion of trigonometric ratios, which we have discussed in our earlier slide, that any trigonometric ratio can be expressed in terms of other ratio. For this conversion, we can use two methods, using basic trigonometric relations or using Pythagoras theorem. We will do both of these methods in our next slide with the help of the example. Also, we can find out all the trigonometric ratios of an angle if one of the ratio is given to us. Let's discuss it with the help of the example. Example 1. Express all the trigonometric ratios of angle A in terms of sine A. Here we are going to use method 1, that is using basic trigonometric relations. We have explained this one in our previous example also. Look here students, sin A equals to sin A. That is sin A is expressed in terms of sin A itself. Now cosec A, we know its formula, it is 1 by sin A. So look here, cosec A, it is expressed in terms of sin A. We know one more formula, cos A, which is equals to root under 1 minus sin square A. So cos A is also expressed in terms of sin A. Now for sec A, we don't have direct expressions in terms of sin A, but we know the formula sec A equals to 1 by cos A. Now what we are going to do is we copy numerator as it is, and in the denominator we are using the formula of cos A, that is root under 1 minus sin square A. Now sec A is expressed in terms of sin A, that is 1 by root under 1 minus sin square A. For tan A, we know the formula sin A by cos A. The numerator sin A, same. But in the denominator, we are going to replace it again the same formula, that is root under 1 minus sine square A. Look here students, now this tan A is also expressed in terms of sine A. Now one more ratio left over, cot A, whose formula is cos A by sine A. In place of this cos A, we are going to replace it by its formula root under 1 minus sine square A and denominator sine A itself. Now look, the cot A is also expressed in terms of sine A. Here all the 6 ratios, that is sine, cosec, cos, sec, tan and cot, all are expressed in terms of sine A. Students, once again, we are going to express all the trigonometric ratios in terms of sine A. But here we are using the second method, that is using Pythagoras theorem. Let ABC be a right angled triangle, right angled at B. Here it is. Here hypotenuse is the side AC, which is opposite of B, and for the angle A, for reference angle A, the perpendicular is BC. It is P here, perpendicular BC, and AB is the side AB is the base. Now let's suppose sine A equals to K. It can also be written as sine A equals to K by 1. We know the ratio of the sine A, that is perpendicular by hypotenuse. This one is the ratio of sine A. So, if hypotenuse equals to 1 unit, then P equals to K units. Now, using Pythagoras theorem, we have B equals to root under h square minus p square. Let's substitute its value, that is h is 1 here, so h square is 1 square, minus it is here, and p is k. Look here, p is k, substitute it. So we have b equals to root under 1 square minus k square. Now let's express all the trigonometric ratios in terms of sine A. First, cosec A. The cosec A is the ratio of hypotenuse to the perpendicular. H by P. Let's substitute its values from here. We have H equals to 1 and P equals to K. Now we are going to replace this K by sine A. Look here, K equals to sine A. So let's replace it. 1 in the numerator and K is sine A in the denominator. Look, the cosec A is expressed in terms of sine A. Now cos A. The ratio of cos A is B by H, base by hypotenuse. Let's substitute the values from here. Base we have calculated, B we have calculated from here. It is root under 1 minus k square. And in the denominator h, value of h is 1 from here. It is 1. Now substitute this k by sine A again. So we have root under 1 minus sine square A. Cos A is also expressed in terms of sine A. Now sec A. The ratio of sec A is h by b. Substitute their value. H is 1 and b is root under 1 minus k square. So we have its value as 1 by root under 1 minus sine square A. Sec A is also expressed in terms of sine A. Now for tan A, the ratio of tan A is P by B. Substituting their value from this part, we have P is K and b is root under 1 minus k square, which we had calculated in this part. Again, let's replace all the k by sine a. So we have the result k equals to sine a in the numerator, and in the denominator we have root under 1 minus sine square a. So tan a is also expressed in terms of sine a. One more ratio left, that is cot a. Its ratio is b by p. Substituting the values, we get another step. B, it is root under 1 minus k square, and p is k. Replacing all the k by sine a, we have root under 1 minus sine square a by sine a. All the ratios cosec a, cos a, sec a, tan a, and cot a are expressed in terms of sine a. Now let's do some more exercise. Let's find the other trigonometric ratios when one of the ratio is given. Let's take an example. Here, one ratio is given, that is sine theta equals to 3 by 5. You have to find two more ratios for the same angle theta. That is, you have to find the cos theta and tan theta. Let's find it. Given sine theta equals to 3 by 5. The ratio of sine theta is p by h. Comparing, we have if h equals to 5 units, then p equals to 3 units. Now using Pythagoras theorem, let's calculate b, which is equals to root under h square minus p square. Let's substitute their values. H is 5, so h square is 5 square. Hence we have root under 5 square. Similarly, substituting p as 3, we have 3 square. Now 5 square is 25 and 3 square is 9. On calculating, we have it is root under 16, which is equals to 4 units. Now cos theta we have to find. Here it is cos theta. Its ratio is b by h. We have calculated the value of b as 4. So let's substitute it. There is 4, and h we already had in the question. It is 5. So cos theta is 4 by 5. Again, let's find tan theta. Tan theta, the ratio is p by b. P, we had it from the question. It is 3. And b, we have calculated it as 4. So here it is 4. So tan theta equals to 3 by 4. One more example. Given that 5 tan theta equals to 4, you have to find the value of this trigonometric expression, 3 cos theta minus 2 sin theta by sin theta plus 2 cos theta. Let's start from given, that is 5 tan theta equals to 4. We can also write it as tan theta equals to 4 by 5. The ratio of tan theta is p by b. Again, comparing, we have if b equals to 5 units, then p equals to 4 units. Let's calculate hypotenuse h using Pythagoras theorem, which is p square plus b square. Substitute the values for p and b. We have p is 4 and b is 5. Let's calculate it. 4 square is 16 and 5 square is 25. Adding 16 and 25, we have 41. So hypotenuse is root under 41 units. Now let's find the value of sine theta. Its ratio is p by h. Substitute the values for p and h. P, it is from here 4 units, and h we have calculated just now, root under 41. So we have 4 by root under 41 is sine theta. And let's find the value for cos theta, whose ratio is b by h. Substituting the values of b and h, we have 5 by root 41. 5, it is from question here, b equals to 5. Root under 41, we have calculated from here. So we have the value of sine theta and cos theta. Now let's find the value of trigonometric expressions mentioned in the question. Here it is 3 cos theta minus 2 sine theta by sine theta plus 2 cos theta. Substitute the value of cos theta, which is 5 by root 41 minus 2 it is here, and for this sine theta its value is 4 by root under 41. Similarly, in the denominator, sine theta, it is 4 by root 41 plus 2 is here, and cos theta is 5 by root 41. Let's simplify it. Let's take LCM in the numerator, and also let's take LCM in the denominator. The numerator part, LCM is root under 41. 3 5 ja 15 minus 2 4 ja 8 is here. Similarly, the denominator portion, the LCM is root under 41, and we have 4 here plus 5 2 ja 10. We can cancel this root 41 and this one. Now on simplifying, we have 15 minus 8 is 7, and in the denominator 4 plus 10 is 14. One more step, they can get simplified. We can cancel it with 7. So 7 1s are 7 and 7 2s are 14. Now our answer is 1 by 2, which is the value of the trigonometric expression mentioned in the question. So here it is the answer. Okay students, this much for now. Thank you and have a good day.